We're going to move on to our second speaker here for our morning session. We're going to hear from Thomas Brage of the University of Lund University, who is going to talk about how to include the gender dimension in research in the natural sciences and engineering. Thomas, you have plenty of time until 12:30. You can speak as long as you would like. Let me just say again, if any of you have any questions along the way, please go ahead and throw those in the chat and we'll get to them as soon as we can. Thomas, the floor is yours.
Thank you so much and good morning, everybody. It's very dangerous to tell me that I can speak as long as I want, but will try to stay within the time limits. What I'm going to talk about is then to include gender dimension in teaching. And already here, I want to point out that I cannot distinguish where is the border between research and teaching. And I think that in itself might be a gender perspective. Because of course, when we teach, we groom the future scientists. And when we teach, we present our research, and that might actually form how and what we research. And then, of course, yes, formally, if you are a PhD student, you are both taking part in education and in research. That's also true for master students and hopefully maybe sometimes even for bachelor students and so on. And I'm going to focus on how do you do this and what do we know about doing this when it is not obvious? And I'll come back to that. I also would like just to point out that I draw experience not only from Gender X, which is a beautiful collaboration, but also then from some other networks. We have Genera, which is a network for gender and physics. And then it's LERU, which is the League of European Research Universities. It's a collaboration between 23 or so strong research universities that acts as a lobby and a networking group. And among other things, they work on these topics we're talking about today. So let's get started. I would always like to start with a disclaimer. I'm standing here now and giving this talk, excuse for the horrible metaphor, on the shoulder of a great scientist. And Rita is, of course, a world-leading expert on this. I'm just a professor of physics, but I've been working on this problem for several years, and I will give you my story about how to do it. But of course, we should always approach this with evidence and gender research and so on. But to be able to come anywhere in this time, even if I have extended time, it's quite short. So I will only be able to briefly describe, and I pick out some useful concepts so can help us understand this topic of today. And then, of course, if you want to go really in and fully understand and critically evaluate and all these things, then you have to take time after this and go to the original work. So I use these things to illustrate points. And I might be a little biased towards physics, but if it's true for physics, it's probably valid for most STEM and maybe even beyond. I'll come back to that. As Rita told you, there is a taxonomy, I call it that now, change, which Londa Schiebinger kind of formulated almost 30 years ago. But it says then, as you start off with fixing the numbers, and that is very much true in the subjects I'm addressing here. The lack of women in physics, in maths, and in STEM overall is horrifying. And then we try to fix that, and what happens then very often is that we start to talk about how we should convince women to do physics or maths. And that means we should tell them that they should do this, they should change, so we go into fixing the women. So I add an extra step here. And that is a trap. For example, in my own engineering faculty, they have a program that's called Girls in Engineering. And they go actually not to girls, they go to women in high school. And then they will invite them to show the engineering school and convince them how wonderful it is to change the women. There's many ways you can end up in that trap. And then we talked about instead of sitting in an ivory tower where we don't want to change, we have to start to change our institution and maybe even the knowledge. And I tell you, when I give this and similar talks to physicists, they kind of get sweaty when I start to changing the knowledge, because we are certainly not used to think like that. But of course, numbers are important to the indicator for what is wrong. And this is the way we're going to have the focus. And this is a trap. But a taxonomy means somehow that these categories are separate, that you can separate different actions. And that is certainly not true, especially not for the kind of subjects I'm going to talk about today. So let's forget my newly invented naming and say, no, it's not a taxonomy. It's just some way to build up an understanding. So when is this obvious? Well, Rita has already talked about this, but when sex and gender is a characteristic of what you actually study, then it might be obvious, and several examples were given. So that would be in biology, artificial intelligence, medicine, biophysics, for example, and so on. Or for most of our applied science, that is obvious. Climatology is clearly very gendered. Climate change is hitting women much worse than men, for example. Image processing, and maybe most of engineering, but not all. It's for sure not, especially if you talk to engineers, it's not always obvious. And as Rita pointed out, this is often forgotten, and which is for me very surprising, and maybe for everybody, how forgotten it is. I've been sitting in workshops with STEM scientists, sorry, not STEM, STEM medical scientists in stem cell, I should say. And they were shocked when they realized that they didn't include the sex of the cells they were studying when they reported the results. It was a shocking experience. But what about the rest? In this Gender Innovation homepage, there is some examples, and I will tell you about that, but not so many where it's not obvious. So when is it not obvious? What do I mean when it's not obvious? Well, of course, when the gender and sex is not a part of what we actually study or what it is applied to. But it's also when there is a really strong resistance to even consider a gender perspective. And I come back to that. When the positivistic paradox, which I'm going to tell you what I mean by that, when it prevails, and it's a very, very dangerous paradox. And an example would be then if you go into a math department or a physics department, or maybe some other engineering departments and so on, you certainly end up in a place where there is a big resistance. So what is the positivistic paradox in science? Well, it's this one. Science is positivistic, which means that we consider us to be objective, whatever that is, in our way of searching for the truth. And that means we think that whatever we discover, whatever we learn, whatever we teach, it does not involve or is not affected by the researcher, by the teacher, by the student. We have that kind of epistemology, if you like, that whatever we find, it doesn't matter who finds it. But in the same time, there is a very selected few who actually does that, who actually do the research, who actually do the teaching. And then we get kind of surprised by the fact that if you look at different subjects, the more they're convinced that they are objective, it seems to be a correlation that the more their classrooms, their history, and for sure their boardrooms where decisions are made are sexed, dominated by, let's use the word white men, at least in Europe. Contradiction, and if you find a contradiction or a paradox, this is a dream place for a researcher. So of course, this is a very exciting place to be, to ask this question: why is this paradox so strong? So what are we up against then? Well, when I will tell you a little anecdote or a little metaphor, maybe. Anyway, so if I go and talk to, if I mix with my physicist friends as an example, they might be interested in this question. There, you look out in the universe and you realize there is matter and no antimatter. So that is a question. Where did the antimatter go? I never in my life met, as long as this was even a question, met a physicist who approached this by saying, oh, I woke up this morning and I have a feeling that the answer is that the antimatter doesn't want to be there or something. They always answered this question after thorough research, referring to research. But if the same physicist looks out over the classroom or look into the boardroom and asks, who are the deans in physics, for example, and then they might ask, where did the women and minorities go? I never, hardly ever meet a physicist who would answer that question with research. Let me give you an anecdote. A couple of months ago, I was asked by one of our leaders in physics here to give him some input on why there seems to be something wrong during the PhD programs. Why do women leave after that? And many of you probably have a good answer to that, or some hints. And I did find some answer. And after a week or two, I presented them for him and some other leaders. And afterwards, this person said, oh, thank you, Thomas. That was very interesting. But, you know, I have a feeling that the real answer is, and then, so this is a very common approach that we have to be prepared for. And we have to point out from the beginning, and that's why I pointed out here, we have to go back to research, even if it's not physics or STEM. What are the particular specific resistance you can find? One I think I call the God trick. I've heard this been said. I study electrons and stars. They don't have sex. Maybe they don't. They have names that sometimes implies that they have sex. But anyway, I study differential equations. Their solution do not depend on gender and sex. It's something I heard in the math department. And this is a version of the God trick, first kind of stated by Donna Haraway. But so we pretend, we pick out a little part of what we do. We just look at what we're looking at. And we say we have the God's sight. We know we can look at this without any being effective of who we are. So that is one typical resistance. Another one is this one. I don't understand what you're talking about because I'm involved in curiosity-driven science. It used to be called pure science, but it seems to be fashionable to call it curiosity-driven. And I actually heard Londa Schibinger once give the perfect answer to that. But whose curiosity? Why is your curiosity more important than anyone else? Because your curiosity drives your science. So obviously you select what you want to do research on. So what is the conclusion? How should we think about these topics then that don't have an obvious gender dimension? Well, we should start by saying, if you want to define your topic, and we're going to talk about these kind of social issues, the only sensible thing is to say science is what scientists do. It's not what we study, it's what we do. So that means immediately we come in and we can start to discuss that we actually do a lot of gendered things. We are convinced that our science is quite described in a quite abstract way. So we can't teach it, we can't talk about it. We can't even write an article without in a research journal without using metaphors or similes or cliches even. And they are, of course, extremely gendered because then we entered into the almost the literal literature area. We choose examples. I will come back to that, how clearly we are gendered when we write our examples in textbooks, for example. We name things. And if you look at how we name things, it's really, really interesting. Equation, the best thing you can do, become when you die as a scientist is to become an equation, or maybe even a theory. That is, of course, the highest. And you can just look and at the names of equations and theories, and you can see they are quite gendered. We pick person's name, and then we become gendered. But it's go further than that. We have a relationships to machines that are quite gendered, and I will maybe have time to give you some examples of that. Machines are sometimes named, or labs are named after warrior princesses or quite girlish names, and the relationship between the researcher and the lab machine then becomes interesting, and how we consider that we kind of conquer the machine and the science and so on. Particles, yeah, I don't know, is particle names that they have properties such as charm. Is that maybe gendered? We represent science with labels, so representations become important, and we represent them with diagrams and pictures. There's a wealth of that. That could be gendered. And we use role models, as you saw earlier. And of course, maybe the most important, we choose our methods, we choose our teams, we choose our collaborations, and we choose what to research. So here enters, of course, a gender dimension, which actually also form the science we do. So I want to tell you one little anecdote about where in a science field which couldn't see this gender dimension, the use of the GRA homepage actually was quite successful. So what they found, we had a workshop for this group. I'm soon going to tell you what group it is. And Londa Shibigan came to Lund, and she led it together with us. And we actually quickly found some very useful methods from the GRI homepage, the Gender Innovation homepage. They could rethink the research priorities and outcomes. Everybody can do that. We can rethink language and visual presentation. And this was the combustion physics division. And of course, this is applied science, but they still couldn't see why all their researcher, all their PhD, and most of the students, well, almost all of the students taking their courses were men. They had one woman working at the division, and that was the secretary. So then they started in this discussion, and they said, well, how do we do our teaching? How do we present our research? And they realized that they were giggling almost. They were very fascinating about machines. They were very fascinated. They always used a car and how to make a faster car or so on, and how the combustion engine in a car worked was the main thing. And then they start to realize that when they do that, why don't they measure the environment impact of the cars? And why don't, since that's actually what they research on efficient combustion. And since 70% of all the energy production in the world is combustion still, so it's a very important mental issue. Now, I don't want to be what is called essentialist here, which I mean say, oh, environmental is for women and cars are for men, but we are groomed in that way. We know if we talk to boys and girls that very early they are in school, from friends, from parents, from society, from movies and so on, groomed to have a certain interest. Nowadays, they have extended their lectures, they have extended their research output, they have started to do atmospheric science. They have become better, I would safely say, at least they become wider, and they now have several women working for them, and they also have, I think, about 30% of their PhD students are women. So, and the interesting thing, this is anecdotal, but anyway, the interesting thing here, it seems like the transformation of science went hand in hand in the transformation of the numbers, so to speak. Okay, I talked about representation, and I will give you a very simple example here about visual representation, which is maybe the strongest representation you can have. We were using in Lund a typical introductory course book in physics, and of course this becomes very important for the future generation of physicists. This is the first book that presents physics in Lund, or physics overall maybe, on the academic level for our students. We had used it for 15 years, which is in itself quite tragic, but then one of our students said to me, and I was the director of studies at that time, why do you use sexist books? And I gave the obvious answer to me, we don't, we have physics books. That's clear, but I should have been kind of suspicious, because one of the first pictures in this book is this one. I don't say this necessarily, I think it do, but it's not the one that is sexist for sure, but it came, looking through the pictures and encountered this as the first one. It's very fascinating for the author, because we have an airplane here flying at a high speed towards the right, and still the bombs fall in the straight line. So it's an illustration of relative motion. And I remember some of my teachers even said, oh, look, you can measure the air resistance because they slightly deviate, and so on. At that time, I realized, and it was kind of a shocking feeling for me, that I had a few weeks before had a discussion with one of our students, and he was suffering from post-traumatic stress. He was a refugee, and he had been coming from a place where he was living down here. So this picture suddenly became for me then, and for obviously for that student, something different, because he had lived there. And the picture means something completely different than from the almost gigglish discussion from my teachers who lived in Sweden, where we had peace for 220 years. But this was the sexist picture. So in this book, the author chose to illustrate the parallel mirror trick, where you have, you go into an elevator. This is obviously not from an elevator, but anyway, and you have a mirror on each side, and you see an infinite number of images of yourself. Now, many people, when I said I withdraw this book because, among other things, this picture, people said, oh, come on, is it really sexist? It's a woman in a swimming suit. Well, it's semi-transparent. So, but my answer to that is, if you have experienced sexual harassment, which I know that about somewhere between 20 to 50% of my women students will do, it means something different to you. So we have to remember that when we judge sexism, we have to let the people who have some sort of experience of it to have the right of interpretation. What were the pictures of women in this book? Well, here they are. Those were the real women in this physics objective textbook. Women are obviously ice skaters, they are dancers, they are pink dressed girls on red bikes. This is last one is somewhat against the norm, maybe, or stereotype, because it's a javelin thrower. But anyway, there's a selection. Even the coloring is interesting. And here are the men. And these are the pictures of real men. So men they are scientists, and they work in industries, and they lift things. They're astronauts, and they climb and so on. And just look at the coloring. I thought that was interesting. So of course, this is not any longer not gendered in this first textbook that was given to our students. Sexism, I would like to point out, one of the big idols in physics is Richard Feynman. He was funny. He was also a very good pedagogue in many ways because he could explain physics, but he also wrote strange things. He explained one of his discoveries like this. That was the beginning, and the idea seemed obvious to me and so elegant that I fell deeply in love with it. And like falling in love with a woman, it is only possible if you do not know much about her, so you cannot see her faults. This is in a physics textbook. Is this sexist? Well, this has been discussed, but certainly it gets worse. He liked to draw nude pictures of women, students among them, but also of Marie Curie. The message I intended to convey was nobody thinks about Madame Curie as a woman, a feminine with beautiful hair, bare breasts, and that. They only think about the radium part. And this is a comment to one of his nude pictures of Marie Curie. And this idea of this bohemian scientist sometimes go terribly wrong. If you watch the Big Bang Theory, you might be endeared by Sheldon, but this is Sheldon, the evil, the dark side of Sheldon. He thought about his excellence, his rule breaking, and he became obviously also sexist. Do Google, this is an ongoing discussion. And of course, it's very interesting to read the defense. I mean, Richard Feynman is a Nobel Prize winner and he probably deserves it from that point of view. But at the same time, you have this. And what do you convey to future generations if this is the kind of wording you use? Now, coming to the knowledge production, I have an example here also. And now we go back in time. But if people say there is no sexism in science, let's go back to William Gilbert in the 1600s. And at that time, they had discovered that there was something called magnetism, and there was something called electricity. Magnetism was useful because you could make compasses so you can navigate ships. And it was an active thing. Magnetism happened by itself. It was active. Electricity, there was something useless, inactive. It was considered feminine. And you can see that by even its name, because electricity comes from electron, which is the amber stone in Greek, I believe, which represents the tears of women. So it's the female mourning, it's the water. And water was one of the elements that were female. Now, time went on, and 200 years later, it was electricity who was the important. And when it became useful, it was not any longer water, it was fire, it was male. And if you want to hear more about this fascinating topic, go to Helena Goetschel's Plotina talk, and I have the link here. And she actually addresses this, the same thing that I'm in a more whimsical way maybe addressed today. If you want to go deeper, before I step a bit back, you could go into the epistemology. And if you want to do then with something that is not obviously gendered, maybe you want to ask what is the understanding of how we can know things in physics. And I would then recommend, even though it's terribly tough for scientists, Karen Barage's Meeting the Universe Halfway. And basically she's talking about agential realism. And she points out that there is something very interesting. The old physics, the Newtonian physics, is objective and extremely positivistic, right? Basically, what we discover, what we research there is a scene. We are the audience. We will not affect the scene at all. But quantum physics, as she points out, might offer something different. And that brings in the Copenhagen interpretation of it and so on. So she says, the reality and the observer, the experiment is entangled. You can't distinguish them. These three components of a research is not possible to separate. And she calls it, it's not relativism, it's agential realism. So, what is the conclusion from all this? Well, as you can see, everything, all the examples I'm giving are creating knowledge, but it's also very much linked to the culture. And what you will have to say then is that culture and subject are intertwined. So this taxonomy of separating, and I never said that that was the intention when they were, but anyway, they can't, we shouldn't understand them as separable. So culture is breeding certain leaders, and they make the priority to shape science. Culture creates this image of science and the scientist, as we saw, which affects the knowledge production. And if you want to understand knowledge production, we need to understand the culture. So the rest of my time here, I need to go into a little bit to understand the culture of this part of science. And I use physics, and that's too, I'm a physicist, of course, but it's also the one where you can find a line of studies. But of course, it seems that it's great to be a physicist because people really love to study us. But there are several myths that I would like to draw upon here. There's one that comes from far ago, long ago. It's the culture without culture. But it's been confirmed over and over again. Oh, sorry. It's something that you can go back to a wonderful book called Pythagoras' Trousers, where they talk about scientists in these fields being like a priesthood. I will not talk about that, but it's interesting to consider that maths and physics and some parts of science came from theology and philosophy. We always think about physics and religion as combating each other, but actually they were unified. And they were fighting for proving the God's existence against mysticism and other things. While the other parts of science are actually coming from more practical backgrounds. Biology stem maybe from agriculture or from medicine. Chemistry maybe came more from, among other things, creating gold and so on. There is something about Hercules culture, and I will also talk about the myth of effortless success. So the culture without culture came a long time ago, and it came from this beautiful book by Sharon Travick on beam times and lifetimes. And she's an anthropologist, so she, instead of going to a remote village somewhere and study the population, she actually went into the physics labs and she picked two. And what she found then, and she coined, was this interesting thing about that we were longing for the objectivity. And that's longing was so strong that we had the idea of whatever we do, we are objective. So since our knowledge production is considered objective, we can interact with other people, we can make our choices in an objective way. What she also found is that independently of which laboratory she was in, the description of excellence was very different, but it was always male. In SLAC in California, for example, it was discussed as something that you have to be strong, independent, sharp elbow person. While in Keck in Japan, they was described that you had to make compromises, you had to create networks and so on. In both, and actually in Keck, they said women cannot be leaders. They can't be considered excellent because they are too competitive. So whatever you describe excellence as, it became male. There was a big and interesting discussion about the relationships and the naming and so on of machines and the nature, which I have a little bit illustrated for you, how the scientist becomes the man and nature becomes the woman who should be conquered. And then grooming of new generation is also an interesting discussion on. But later research has shown and confirmed this problem here. The stronger the myth of objectivity, the more subjective you become. And this is like believing that you are objective. You learned objectivity. It's like vaccination, so you will never be subjective again. Then you become more subjective because you don't question what you're saying. So this is the interesting thing then. What direction is it? The belief of objectivity gives objectivity and knowledge, will that influence our culture? No, probably not. Because the more objective we believe our knowledge is, the more subjective our culture might be. And how about the other way around? The more, if it's true then that our culture is very gendered, will that more influence our knowledge production? Another example, which is very interesting and it illustrates the point. It's a couple of years ago, but this Hercules myth have been reproduced since then. But I just go back to the original because it's kind of interesting. In this research, they tried to explain or address, I should say, the different percentage of women among physics professors in 5 countries. And here are the 5 countries. And now I would like you to participate in a little exercise. I'm going to count to 3. And when I say 1, I want you to unmute yourself. And when I say 3, I would like you to answer, shout, or you don't need to shout here say the answer to my question out loud. So you have these 5 countries in Europe. And my first question is, which one do you think had the highest percentage of women among physics professors in 2008? So on 1, you unmute, on 3, you answer. Okay? Are you all with me? 1, 2, I see no unmute buttons. 3, answer.
Italy.
Denmark.
Italy.
Great, all countries were mentioned, that's great. And now we do the same thing, but the opposite question. And which one has the lowest percentage of women among physics professors? 1, 2, 3.
Estonia.
Poland. Turkey.
Italy.
There's no answer, Turkey.
Okay, at this
that.
time, 2008, Denmark had 3% women among their physics professors. Estonia 11, Finland 12, and Poland 14, and Italy 23. Yes, Italia. Might you even be that successful tomorrow? I don't know. Anyway, this is an interesting result. It's almost an order of magnitude difference. And of course, you can ask the question, why? And you know what? This is the interesting thing. Everybody has an idea of an answer now, right? But this is a very thorough research. There are many thoughts, and of course, there are many reasons that these things happen, which are outside the academia, but maybe not the strongest. We know from research on harassment and on bias that always addressing things outside is not successful. You have to go inside. You have to ask about the culture inside the department. And they found a culture within physics. And they found 3 different cultures. Let me read them to you. Hercules. Oh, yes, this is a question on how did you, okay, I should say that. This is interviews of professors. So it's a sociological study. How did you become a professor? Oh, yes, there is a lot of competition. The whole process is extremely competitive. The case that the department needs to make to the university is that I'm not only good enough for the job, but I'm the best person in the world of this job. That's a Hercules. A caretaker says the opposite. There's always a team behind the genius. Good teamwork always brings the best results, but of course, not everyone is lucky enough to find a good group to work with. Sometimes when there are very competitive people, it is difficult to form a group. And then we have the third, a little bit sad descriptions, but in this respect, for us not to show ourselves too much and do crazy things, we had to sit quiet and pretend we were not there. If you want to make a career, you can't rock the boat. Denmark, welcome to Viking land. Hercules for sure. Estonia and Poland, working bees. Italy, a caretaker. A correlation. Finland is a beautiful country with a beautiful culture, but in this case, it didn't show a clear culture. But we have to remember that this is the perception of culture. And we know that if you have this Herculean excellence, strong base, you are not doing very well in recruiting new groups. because we are groomed in academia to look for excellence in the mirror. So we are so convinced a successful person is an excellent person, and we want to be successful. So kind of, we know this from research, right? That definition of excellence are very similar to yourself. And of course, this is a problem. And I must say, I think it's not completely true that even in Scandinavia then, that it is really Herculean, because I see caretakers in the lab. But we like to describe ourselves like that. So we go back to this Feynman, bohemian person. We go back to all these other ideas I brought forward. And we see a picture emerging where we try to think about ourselves in a way that we are not. So there are many more books that I can recommend, some of them very new, like the Gender Sensitive University, which comes out from the SAGE project, the Inclusive Academy. We in Lund has focused on core values when we talk about these things. So if you want to look up some example of actions, you can look at that. The last example is the myth of the effortless success. And this is typical science. And it's very interesting. Well, first of all, some good news. According to the research in this very recent book, boys and girls in schools are equally interested in the methods of science. Both girls and boys say that the fact that you can use mathematics, that you can do experiments, you can develop things, so to speak, this mix is attractive to them. And according to this sociological research here, it's equal between boys. They couldn't see any difference between boys and girls, but boys and girls are interested in different applications. And this is very good news for scientists, because applications we can change, but it would be quite mind-boggling to try to change our science, because we would become something completely different. I'm talking now the core of the science, the methodology. No, not the methodology. The ideas of using math and experiments. A recognized myth that was an objective to minorities was also the successful scientists are doing science effortlessly. And this is so false. I usually say that I recognize the idea that you have students coming in early years and they do things effortlessly. And they have, that is the way of success. And you know, so often I find them somewhere along the road, and it's not effortless any longer, because somewhere, at least when they start on the master project or somewhere, it becomes hard and they don't know how, because they haven't learned the techniques, the study techniques to deal with that. They have to change the self-interpretation somehow. But effort, the correct, and everybody agrees, and it's much more inviting to say, if you work hard, which you will have, like in all research, then you will succeed. That is more invited. And effortless, we have to remember, where does that come from? What is effortless? Well, it depends on which school did you go to. And it's a very strong relationship or relation between people having scientists as parents and feeling it's effortless. So of course, if you have a home which grooms you, it's of course effortless. If you don't understand the metaphors, if they are using, for example, examples, where you pick example, or you focus your research on things that are from a selected number of topics. And what the women interviewed in this book talked about was, it's a lot of superheroes in their examples. And I never read superhero books. And again, not essentialist, but of course, different groups of people are more or less interested in these things. So effortless success is it's effortless for you because you happen to be among the selected few that fits in, you belong. Why do we need to do this? Diversity gives diverse perspective, and of course, then more excellent. But you then have to groom your leadership, because the leaders have to understand diversity and how to lead diverse groups. Otherwise, it's problematic. So if I understand my sociologist friends correctly, you will get the better results. It might take a little bit longer time. And if you're not managing the group correctly, it goes to pots. So here's just some Nature articles that recently came up and prove this to scientists, that you should. And diversity is, of course, not in a person, it's in a group. So you have to go away from Hercules and think as science as something produced by groups. And this is obviously true. Go to CERN and you have thousands of people collaborating on each project. It's a group of effort. And this was actually true in the old days too. If you go into the labs in the 30s and 40s, the people whose song or story was never told, because at that time, the author was only the head of the department. They were diverse, actually. If you go to England in the 30s and 40s, there were many people from different parts of the world contributing into the labs, but their song were never sung. So I just also want to tell you about, there is a toolbox from Leru on this. It's a little bit outdated, but it's from 2016 that you can look at for action tools on these things. And also, hopefully, there will be a Genera conference, if I may here promote our sister groups a little bit. We hope to, in August, we're going to meet in an advisory board and decide whether we're actually going to be able to have it in October. But otherwise, we will postpone it. We want to meet in persons. We don't just want to sit like this. Now, I have a few minutes left. And now I want you to all think for one, you get 2 minutes, on one line summary from what I said. And then I'm going to write that down here. So I give you 2 minutes to think through, and then we see what summary you would bring out from this, and maybe also from Rita's talk. So I stop sharing and let you think for 2 minutes.
You can put your comments in the chat. It might be a little bit easier way to manage it.
Yeah, and this way you can answer in both language, and we can get it translated maybe also. That's 1 minute past. Okay, do you have any? Can someone read up or just shout out some summary, important takeaways?
Maybe I'll take on that job as the moderator.
Yeah.
Science is not as objective as we often thought, I'm guessing is the last word there. Academic culture could use pushing Hercules off the pedestal, or not putting Hercules on the pedestal. Success is never effortless. Otherwise, there needs to be a trick. True. It's true. They really never tell you how hard it's going to be sometimes. And I say this as somebody who is a few years into full professorship. I mean, even after all the, you're at the top of the food chain, so to speak, and it's still hard. Anybody else have a comment? I just wrote something very similar, the way that the culture of science and its dedication to objectivity has impacted, everything in the, in STEM fields, teaching, publishing, research, laboratory culture.
Yeah. And no one can believe that wouldn't affect our knowledge production, right?
Right, right. Rita's mentioning, that we need to really be focusing on lifelong and life-wide learning as a way of doing research, a new way of doing research.
Yeah, this is very interesting because the age is this has been noticed from the Swedish Research Council, where they looked at people evaluating applications. Age is something good for men. Men can pass 70 and still get grants, but for women, it stops around 60 and she is too old. And this was very gendered in their evaluation, and this has been discovered, how age does not become a woman. But also it's a problem that we think that all the discoveries are made around 30. There's some stupid things, I even seen it in textbook. If you haven't discovered it when you're 32, you will not succeed. Like,
Right.
where does such things come from?
Right. Well,
My science was done when I was post 50, for sure.
Exactly. Somebody else said also it's important to have multicultural team collaborations. Let's see, but more important to, you have to manage the groups well, in terms of communication and innovation. Whew.
Okay, great. Maybe we can save the chat, and
We will.
Yeah.
We will.
Thank you so much for participating in that. And I probably said about the same. This I will just to point out, if you ever meet resistance and people say, oh, there's no gender perspective, there are. And Rita has this wonderful trick where you say, just put your subject and gender in Google and you'll find this. So I have some references, and then I just want to thank you for listening to me.
Thank you so much, Thomas. And look at you, finished almost bang on time. Even though I gave you the world, you were still kept to time. I really appreciate that. That was really, great. I mean, if nothing else, for me personally, I have a lot more tools to convince people in STEM fields in terms of, the importance of gender, and just the fact that it's everywhere. I mean, in the sense of, really the whole culture of science, and the way it has ignored gender and intersectionality. I mean, the way it has so deeply rooted itself in what it thinks is positivism and objectivity. And it's just so wrong, basically.